सर वो काका
think so. Now I can. Am I audible now? And from this array, which goes from 0 to 10 with a step size of 0.1. The starting point is 0 and end is 10, both inclusive, which gives us 100 values. And then with this sign of x, we can at the same time calculate the sign of all 100 numbers.
So y is also an array.
Y is also array, yes. Sorry for the interruption. Vectorization is in this Scilab, MATLAB. So there is the concept of vectorization. That means loops are not preferred. And so these functions, they work on array, and all the elements of that array, they will convert to sign or any other function. In general, any function you can apply on. x. If x is an array, then you will get the result also in the form of array. Then you can take this and plot x and y. In this case, the plot function, it requires on the x-axis and on y-axis what should be there. Along with that, x label is there, where you can pass a string. There is y label, which and title, which is plot of x and sin x. If you want to clear the canvas, you can type Scilab. Then sometimes loops are unavoidable. In that case, we can pass from I equal to 1 to n and display I. Semicolon. So this goes from 1 to n. The default step size is 1. So it increments by 1 and n is included. I1 is also included, n is also included. Next, for you can also break in this if I is, let us say, 4, then you can break from the loop. Break is to exit the loop and not the control structure. Then we write x is 5 if x greater than 0, and we can write some value here like display some message positive, else display negative. Then we can also focus on the main most important for us is reusability, and that is provided by the use of functions. These functions, they are working on the concept of write once and use multiple times. Which is, I can write like this, and display and you can also pass another argument and display this. Makes it possible for one function, once you write it, you will be able to call it multiple times with multiple arguments. Here we have passed 3, and second time when we call, we are passing 9. For us, this function is useful in many ways. Always it is a good idea to divide your program in many parts, in small parts, small functions, keep them independent, keep them in different files if possible, but if not required, then even if they are in the same file, write in the form of functions. Then we need them because especially in Scilab, when we use Scilab as a for optimization, we have a function and we would like to find out where we get the minimum of the function or where we get the maximum of the function. Scilab provides certain solvers, certain iterative functions which will iterate and find out from the starting point where is the minimum or maximum value of the function. Usually we will be interested in minimizing or minimum values. Then we can have matrices. Five, 6, 7, 8. Addition and subtraction. It may be possible to have multiplication, then display sum of matrices. And product. Then if your question is of the form Ax equal to B and X will be what given A and B. In that case, you can apply this division as well. It is possible to add also scalar values to matrix if we are adding something, then adding scalar multiplying with scalar values. Now this is very useful. One more thing that you can do is maybe add one column, 1, 2, 3, and B is 4, 5, 6, 7, 8, 9. Then you can create C, which has A, 4, 5, 6, 7, 8, 9. So we can add this column to B to get C. Line 39.
आप सुबह आए तो कहीं को मेरा एक पेपर देखा शीट मिल नहीं रहा है इस पेपर का लिखा था नहीं
Adding a row to a matrix. Such kind of operations are useful. Plotting on the same background. First, create an array. We have sign in y1 and y2 will have cos plot x y1 and red color. Then we have x y2 and blue. Then we can have label y label title legend it will be useful for practicing these basic commands. Find out how we can calculate mode, mean, plot histogram, mean, median, sample, population, standard deviation, and variance. What are certain terms like confidence level, confidence interval, margin of error. Given data like this, 1, 2, 3, 4, 5, 6. Display mean, display median, display standard deviation, for random data, plotting histogram, 10 bins, and number of bins. Especially when data is numeric, for such kind of questions, we plot histogram for describing the numeric data. Histogram tells us does the data follow normal distribution or not. Many other ways are there for calculating mean. One first, R means for row, C is for column. Given a matrix, a different possibilities for calculating mean are given. If you don't give any value, then it will calculate for row. But you can specify by saying apostrophe R in single quotes. If you want column wise mean, you specify in single quotes C. So in this way, variables displaying some value, adding math operations on vectors and matrices, array, which is a type of vector, plot x and y without using loops. There are some functions which can be applied at the same time on all the array elements. Then loops and if else, break. Very important is modules or functions. On matrix, operations like addition, subtraction, multiplication. Solve AX equal to B, you can use this division operation. Adding columns, plotting simultaneously on the same graph. Mean, median, standard deviation. Plotting numeric data in the form of histogram. Calculating the mean for rows and columns. If your data is in the form of table, then each column will be one feature. In that case, it will be useful if your data is this mean operation. It will be useful because for all the columns you can get the mean by specifying this C in the function parameter. With these basic commands, you can calculate variance, mode, calculate the mean for columns in this data set, understand what is sample, population, variance, standard deviation, confidence level, interval, margin of error, and rule of standard deviation, Chebyshev rule, and empirical. Both these rules you can read, so you know what are these statistical terms and their meaning. Another place where the use of Scilab as a mathematical tool will be for performing some statistical tests. Usually on one sample data, that means data of one column or one feature, where there is only a single array, and in that array data of samples are collected. In this one sample data, we have four tests when data is binary, when data is categorical, when data is continuous or numeric, and one when data is ordinal or rank. In this mathematics, since Scilab is a useful mathematical tool where data structures like matrices and vectors are available, we can apply such statistical tests on data. So we see one test which is known as binomial test. This binomial test is applicable on binary data. That means data can have only each sample of data. It can have only two values, which will be coded as 0 and 1. Usually 0 is for the negative case and 1 is for the positive case. In such, when the data is in this binary format, our binomial test will tell us, are the two categories or are the two cases, the negative case and positive case, are these present in equal proportion or they are different from the equal proportion. In other programming languages, maybe there are inbuilt functions available which can give us the answer. Like in Python, there will be stat models or scipy library. In our Scilab, with the use of functions, we can understand how this test is written. That is the advantage of Scilab. Because it has it allows you to perform these basic tests by the use of some arrays and functions. So we have one function which is the formula for this test can be implemented in Scilab. For the formula for this binomial test is given here. This mathematical formula can be applied, can be implemented in Scilab. So this formula has three parts. One is the calculation of factorial. In this function, using recursion, factorial is calculated. We call the function for n and we recursively call it for n minus 1 till n is 0 and 1. This is the this of course can be implemented with the use of loops, which is also straightforward because factorial is simply from n to 1. We have to keep on looping and multiplying. Once we have the factorial, next part is implementing combinations. So combination is given by n factorial divided by n choose k or n k combinations of n. We can calculate by first n factorial, and in denominator we will have k factorial multiplied by n minus k factorial. And then this combination can be used for calculating probability. We keep a variable, then for I from 0 to k, I will store the cumulative sum in the variable SIG is I combination of n e raised to I multiplied by 1 minus p raised to n minus I. So finally, the probability we will get, for example, if total 46 is the size and 12 is the quantity of the first case, and probability of belonging to either is 0.5, then we can calculate the probability p-value, and we have to set a threshold, and then from this threshold we can calculate the p-value, see if it is below the threshold, then your hypothesis will be rejected, otherwise we will not be able to reject the hypothesis. These are the advantages of Scilab. The help of functions. I could have written entire thing in one function, but I chose to divide my code into small parts, and then it makes the code more readable, number one, and I can isolate if at all there is an error, then I can understand which part of the program this error is there. Third advantage is it is write once and use multiple times. Just like this factorial program I wrote, I could reuse it in multiple places. These are the advantages that Scilab offers. Also, other programming languages also offer this. So this other use of Scilab is that it is a popular mathematical tool, and it has these cumulative distribution functions. One such function is the cumulative distribution function for chi-square. For in other programming languages, maybe you will have to import some libraries, but in Scilab, this function is available. You don't have to import anything. That makes that we can use to our advantage. Scilab being an old programming language, which is under the control of a reputed organization. So we can be sure that these functions, they have been tested and they cannot, they are precise. In languages like R and Python, where anyone can create their library, there is a scope for error. Certain reputed libraries are there, yes, but since anyone can create their libraries, so it is a risk to use some lesser known libraries. So this cumulative distribution function of chi-square is a very useful mathematical function in Scilab. And this mathematical function, use of this mathematical function is inside one test. We can demonstrate the use of this function with the help of another statistical test, Pearson goodness of fit. So just before we go to Pearson test, just note note how these functions are written, the syntax of the functions, and advantage of writing once and reusing multiple times. How in this program we have demonstrated the use of functions for for implementing one mathematical concept. Now I will demonstrate how this cumulative distribution function is useful, especially applied on the chi-square distribution. So we have this CDF by function. In this we can pass the degree of freedom and the values. We have one matrix and degree of freedom. So what we do, we can demonstrate the use of this with one more statistical test. As I said, this is the theoretical goodness of fit. In this test, in this we we may deal with categorical data. So the question can be, is there um, uniform distribution of animals in jungle? That means there can be lion, there can be tiger, and there can be deer. Three animals may be there in the jungle, and are they equal in equal quantities or in equal numbers or not? Since we do not have the resources to track the entire forest, to count all the animals in the forest, so we focus on one sample. And in that sample, you find that deer is 16, tiger is 17, and lion is 20. Given the presence of animals in this ratio, can we say that the categories are equal, or can we say that if the sample is like this, then the population will also be in the same distribution, or whether the sample cannot give us an idea about how the population will be distributed. Such kind of questions require the use of this function, cumulative distribution function of chi-square. If you read about this distribution, it is widely used in statistical fields. And in other programming languages, we have to import packages. If you are using Python, then there is SciPy, there is stat models, there is ResearchPy, there is Penguin or Pangua. Such kind of packages you have to import, because these statistical functions are not present in the basic distribution of Python. The basic, it is not an inbuilt library of Python. The advantage of SciPy is that these mathematical operations are present in the base code of Scilab. So you don't have to import different packages and deal with some package may change, or they may lose their compatibility. This package may not be compatible with that package. So keeping track of the versions, that is a problem with the Python, that I have to keep a track of versions of different libraries. And these libraries are not a part of the base distribution. And who knows who is maintaining these libraries? Some are, of course, SciPy is reputed. But with Scilab, the advantage is that all these mathematical operations are a part of the basic code of Scilab. And so you don't have to keep a track of versions of package and download this package, install that package. That you can avoid. With the use of Scilab. Another use, as I said, another advantage of Scilab is that it is maintained by one reputed organization. And it is a older programming language. So, keeping in mind these two advantages, some organizations will prefer using Scilab. And the syntax of Scilab is close to the syntax of MATLAB. But MATLAB being paid, is not available for everyone. So Scilab and Octave, these two programming languages are kept as options for prototyping, where MATLAB and MATLAB, unless it is absolutely needed, at least Scilab and Octave will give you a start. Ideally, if all the three categories are equally present, then I should find that I can expect that each category will have 18.33 or close to 18.33. I am observing that all the three categories, they don't have 18.33. So, element wise, okay, this dot stands for element wise. Subtract from one array one scalar value from each element of the array. Element wise take the square and then divide each element by the expected outcome. So the syntax is a bit difficult, but it is similar to other programming languages, Octave and MATLAB. Then the functions of Scilab, like this length function that counts the number of elements, helps us to avoid the use of for loop for the same purpose. Now we have got the degree of freedom. As I said, you don't need to install the chi-square distribution function. We can directly use the function in this way, CDF chi. Now we want to calculate the p-value, which we will get in this way. Then we can display the p-value. So with this program, we can demonstrate how this chi-square distribution function can be used, how element-wise calculations are performed, and how this all this can be applied to implement the goodness of fit test. To apply the same test in Python, you may need some libraries, because I don't think these cumulative distribution functions will be available in the base distribution of Python. And when you use libraries, you will have to keep a track of their versions. Other than this cumulative distribution function of chi-square, the cumulative distribution function of the t, or the normal distribution or t distribution, ds or t, which is similar to the normal distribution, that is also available as with the base code of Scilab without any installing any outside function. For in Python, the same cumulative distribution function of t, the t curve, that will not be available directly without the use of library Scilab or stat models. In this program, we can see how this mathematical function is available in Scilab along with other mathematical functions like length of array, mean at standard deviation, and square. And absolute value. These are certain mathematical functions: mean, standard deviation, square root, and absolute value, which are available in the base distribution of Scilab. Although these will be also available in the base distribution of Python, but this cumulative distribution function will not be available. For that, you have to import libraries in Scilab that can be avoided. So to demonstrate all these 5 or 6 functions, we will see one statistical test known as the student T test. In this test, we check whether the numeric values of the sample values, which are all numeric, are they equal to what is the average of the data? Is it equal to some hypothetical mean, or is it different from a hypothetical mean? Since we will not go into the details of this test, there are many versions. There is one-sided, two-sided. We don't have to worry about those versions. I want to focus on how these functions can be used. So I will implement the two-sided test. In this two-sided, we only understand whether the average is different or same. Is it different from a particular number, or is it equal to the particular number? So let us have dummy data. Let it be this dummy data. I want to find out whether the mean of this is equal to 14.5. So normally questions that may come is this feature of the data set. Is it on an average, is it on an average equal to 90? Or is the average age of the population equal to 21? Such kind of questions require you to use the t-test, where you have to prove that the average is equal or different from the hypothetical average. So first, to implement this test, we need the length of our array. We need mean and we need now standard error. Standard error is standard deviation of data divided by square root of n. Again, these functions demonstrate how we can avoid loops. Length, mean, square root, standard deviation, not square root, but standard deviation, ST10. These are all applied on arrays. But without the use of loops, they are giving us the answer in the form of number. Next, the t distribution. T value is mean, which is mean of data, minus hypothetical mean divided by standard error. Then for the degree of freedom, which is n minus 1, we have to find out one minus तो आप पढ़ना चाहते हो? रुक जाओ, सुनना है।
सुबह जल्दी उठना पड़ता है ना सर।
मैं तो जा सकते हैं।
पढ़ता हूँ मैं।
with the Okay, so with this, several functions of Scilab like length, mean, standard deviation, square root, absolute value, and cumulative distribution function. These can be demonstrated.